Hey guys, Buildzoid here, and today we're going to be talking about coil whine and what causes it, as well as some theory on how you can mitigate it. Personally, I've never tested any, I've not scientifically tested any mitigation method for coil whine. I just don't care that much. Most of the cards that I have major coil whine on are cards I use for benchmarking, and when I'm benchmarking, I have, very high RPM fans running, so the coil whine is kind of a secondary issue at that point. Doesn't really annoy me that much. But so, I've not tested any mitigation methods, but the theory of why you have coil whine, does give you a pretty direct and relatively obvious answer for how you should fix it. So here we have a whole bunch of inductors, and basically, this is a type that's this right here is a type that is really common for relatively low power applications. And you can clearly see the coil in there. That's where the coil whine name comes from. There's also inductors in power supplies that have quite different construction, but you don't see those on GPUs or motherboards, so we're just going with the ones that you would actually encounter in a GPU or a motherboard, which would be liable to coil whine. But anyway, this style is relatively popular for things like memory power, memory controller power, various supporting rails if you have a lot of space on a PCB. This one comes off of an RX 480 from XFX, and I think it's from the memory power VRM. And basically, this style shouldn't really coil whine because, as you can clearly see, the coil is wrapped around a sort of core inside the block here, and then it is sort of glued in, so there's adhesive holding this whole thing together, and so it should be relatively good about not vibrating, right, once it's installed. And the same can be said for this one. Here you can actually see the glue a lot better. So yeah, you can just see that seems to be some kind of epoxy type thing, and that's just held in place, so this isn't going to coil whine with most probability. Same goes for this style, right? That's not going to coil whine either. And I think this one comes off of a GTX 570 I had, and I don't think that card had any coil whine. But anyway, what does tend to coil whine a lot is this style. And you should, if you had a R9 290X, these should be pretty recognizable. Gigabyte used them on a few motherboards. Those coil whine as well. So this style of inductor, very liable to coil whine, and most of that's down to the way these are constructed. So you can see that line over there. This is basically two metal slabs sandwiched around a metal tab, like so. And the problem with that is, if the metal slabs get loose from the metal tab, they're free to vibrate pretty much as they want, which is kind of true for these as well, but you can see that the adhesive used to hold these together is a lot thicker than on these. And so these tend to make, if you have a card that uses this style of inductor, it's pretty likely that it also has coil whine, because let's just go through cards that use this style. Vega uses this style. Vega's coil whine, the reference boards do. The R9 290X, this style of inductor, also has coil whine. Fury X's sometimes have coil whine, still this same style of inductor. What else? GTX 480s, at least the one I had, coil whined. So you run into a lot of just this construction style is just inherently worse for coil whine. Unfortunately, it's really, really popular because these are really high current capability. So this inductor right here might be good for, it is admittedly only 50 nanohenries or something, but this inductor could easily be good for 60 or 70 amps. This thing is at best going to be 40, 40 amps, maybe 50 amps. So, and this is 30 nanohenries. It's not that much higher inductance than this one. It's twice as much, but it's not that much higher inductance. And if we compare it to, this one's relatively low inductance, but again, this is a tiny little inductor off of a GTX 480. This thing's good for 70 or 60 amps. This is only good for 40, 45-ish. So these are really popular on high-end GPUs because they can carry a ton of current, and they're relatively small. The problem is they do whine a lot. And the reason why it's so bad, especially with GPUs, is because GPUs just exaggerate the issue of the coil whine. And there's one style that I forgot to mention here, so before we go over why GPUs make it so much worse. So this is this inductor cracked open, and this one you might initially think it's the same style as the other ones that are like two pieces. Come on. There. You might initially think that it's the same style as the other ones that are two pieces, but this one doesn't have a separation in the casing. Right? Like this is not two pieces of casing. So what's actually going on with that one is you have the coil just kind of completely molded into, like you can see that wire's just like sticking out of the core material. So that thing is just molded together. So if this is going to whine, it's going to be the whole freaking thing, right? It's not like the coil part of this inductor is separate from the core. They're one piece. They're molded together. So this is really unlikely to coil whine. But this style where it's like three separate pieces, very, very likely to coil whine, especially if they're not like adhesive properly together. And so what you can see on some cards is like Power Color did this on like a few R9 on some of their R9 290Xs. They would actually hot glue all of hot glue the VRM. And the idea behind that is if you apply hot glue to the inductors, it'll dampen the vibrations enough that you won't hear them, right? And then the other thing now let's talk about why the inductors actually vibrate. So we have the construction part down, right? The two-piece inductors, they're more likely to work themselves loose, so the core is more likely to vibrate around. Now, the reason why they're actually going to vibrate is because the way inductors are used, especially on GPUs, they are like you have massive varying currents going through them. So the problem is, right, if you have a GPU that has a TDP of, say, let's just say we have a TDP of 250 watts, right? Let's say that's our TDP. And then we look at a graph of that GPU actually running over time, right? And we look at the power consumption. And so if we have time there and watts here, right, our average power consumption, let's say, is this line along here, right? Which, that'd be great. If we ran that through the inductors constantly, that's a constant amount of current, no varying magnetic field except for the switching on and off of the MOSFETs in the VRM themselves. But the VRM runs at, 300 kilohertz. There's no way you're going to hear that. Unless the inductors are in an awkward situation where they resonate at 300 kilohertz, and then you can hear that. But that's generally not the case. And it also wouldn't explain why your coil whine tends to be tied to your FPS, right? We all know that if you're on a loading screen or a menu screen, you get very high-pitched coil whine because the FPS just goes through the roof. Similarly, some cards, like, say, my HD 7970, has a coil whine that goes up and down with the FPS very across the entire FPS range, really. That card, if you go down to like 50 FPS, it makes a chittery noise. If you go all the way up to 200 FPS, it starts to make a more buzzing noise. If you keep cranking up the FPS, it starts to get into a whine. And the reasoning for that is if you look at your power consumption of, like, say, a 250 watt TDP GPU, what you're going to end up looking at is something that looks like this, right? And so, yeah, your average power consumption is 250 watts, but your peak and your minimum power consumption are very far apart. And the further apart these are, the bigger the change in the magnetic field going through one of these inductors. And if you have a changing magnetic field and a loose metal element that is magnetically attractive, I've forgotten the technical term for it, but wait, this one's too heavy. Oh, there. See? This one. So yeah, this one's really magnetic, rather attracted to magnetic fields. And they all should be to some extent. Yeah, this one also does it. This one's too heavy. Yeah, there we go. The little one does it. That one does it. You can see how they're all, like, all of the core materials are magnetically attractive. So if you have a varying magnetic field and this loose core flopping about in the wind, what do you think is going to happen to it? Well, it's going to start to vibrate, and that's going to produce all of your noise. And the bigger the variance in the magnetic field, the bigger the amplitude of the vibrations. Therefore, the louder it's going to be. And the thing is, this variance in your power consumption is actually tied to your frame rate. So, like, in one frame, right? Let's say there's some operations. So you have some operations sort of at the start of the frame that pull a lot of current. Then it goes down a bit, and then it starts doing something really heavy again to finish off the frame, and then it comes back low. So in one frame, you might have like two two current spikes. And they'll probably be different heights, actually, depending on which specific operations are going on. But what's important is that the frequency of these spikes is based on your frame rate, right? Because through one frame render cycle, you're going to go through a full set of these operations, and a certain set of operations pulls a certain amount of power, unless those functionalities of the GPU aren't being used. So what you can end up with, so as your FPS cranks up, this compresses, right? Your spikes get closer together, and your coil whine gets louder. I mean, whinier, right? Because it goes up in frequency. As your FPS goes down, the spikes stretch out, right? The waveform stretches out, and your coil whine goes down in frequency. And since at low frequencies, it's really like at low frequencies, like these aren't subwoofers. They're not going to make low frequencies very easily. So those you won't necessarily hear very much, because it's actually really hard for a core, like the core of an inductor, to move around at 60 hertz, right? Like that's rather hard to do. But at the higher frequencies, also our hearing is more sensitive to like a certain kilohertz range. So at the higher frame rates, that's when you're going to hear most of the coil whine, because that's when the inductors are going to be vibrating at a frequency we can hear better, and also where the core has an easier time actually doing the movement. And the thing is, with the coil whine, if you want to mitigate it, right, you have to keep in mind that on a GPU, you don't just have the VRM. So here we have a Vega, right? And if you wanted to mitigate the coil whine, you'd basically want to dampen all of these inductors right here. You wouldn't need to necessarily worry about all of the minor rails. I mean, in some cases, they might actually be causing it, but these are very small inductors. So if they were vibrating at a frequency that you could hear, they probably wouldn't be doing it very loudly. And also, these are your minor power rails, and they really shouldn't be experiencing big load cycles. Your big load cycles on a Vega are going to be on your vCore VRM and your input filters, right? These are the two inductors everybody kind of forgets about. So VRM is this thing. So you could initially, and this one's memory power down here, so this one's probably unlikely to whine a whole lot. But these two and this entire vCore VRM down to here, very likely to produce basically produce all of the coil whine the GPU produces. And the reasoning for that is that's obviously where your biggest load swing, your load current swings happen. And so if you were going to be, trying to dampen it with like high temperature silicone, hot glue that, melts at a temperature higher than the VRM runs at. Keep in mind, VRMs can run at, 110 degrees, and it's perfectly safe for the MOSFETs. Now, certain types of inductors will actually degrade over time if you run them really, really hot, but it takes a while for that to happen. Ultimately, and a lot of reference cards, if you have like an R9 290X reference, which those are notorious for coil whine, those things, the stock VRM there runs like 90 to 110 degrees. So you do need to actually use an adhesive that's not going to degrade at the temperature that the VRM runs at, which is why I'm saying high temperature silicone or some high temperature hot glue. Because if you use, say, Plastidip to do your VRM, I've got bad news for you. Plastidip degrades at 95 degrees Celsius. It's not rated past that temperature, and basically it starts to harden and crack if you keep it at above 95 degrees for long enough. So if you wanted to like Plastidipping this VRM would just not work, right? That wouldn't work. Eventually it would break down and you'd have your coil whine again, but you would have to basically high temp silicone all of your vCore VRM and the input filters for the vCore VRM, because any load current change that happens to the vCore VRM, right? If the GPU core is pulling 50 watts, then it's pulling 50 watts from the VRM. That VRM is pulling its 50 watts from the 8 pins, and between the 8 pins and the VRM are these two inductors. So if the core starts pulling 400 watts, it's going to ask the VRM for 400 watts. The VRM is going to grab its 400 watts through these two inductors. So they're still going to see that load, that current swing change. Now it's going to be reduced because you do have all of this bulk capacitance on the input of the VRM, right? These black capacitors over here, they're there to try minimize some of the current change swings so that you don't just dump a bunch of noise onto the 12 volts of your power supply. But the input filters are still going to see quite a big change in current pull, and that's still going to lead to coil whine. So you're going to want to do those as well. Now, the one last the other type of inductor that we've not looked at here is actually, there's a lot of different styles of construction, but this is also a style. This is really rare these days. Like, these were only popular on, like, older AMD GPUs. This is like a coupled core inductor. These things are terrible. These things are by far these are probably some of the worst for coil whine. And the reasoning is really, really simple. That's a big inductor, and you have basically one big core for your 3 separate coils. So if you pull 40 amps and then go to 100 amps, or, you know, some kind of load change, that affects the entire freaking thing, right? And that means you have this big slab of metal that can rattle around if it's loose. Now, it's not actually loose to the touch or anything, but my HD7970 uses this style of inductor for both of its V-Core VRMs. That is by far the whiniest card I own, probably because of this style of inductor construction. So yeah, that's not great. And the rest of the VRMs on this card and the input filters aren't much better, right? These guys down here are this style. So those whine. That thing right there seems to be one of those molded types, so that's not really a concern. It's relatively, yeah, it seems to be relatively high inductance, so that's probably molded so that they can get the coil inside. And this one over here, yeah, that's you know, one of the whiny ones again. So yeah, this entire thing is like, as far as inductor choice for their acoustic properties goes, this thing's kind of terrible, right? Like, and you'd really want to just plasti dip everything. Like, you'd want to try cover everything on this. So yeah, that's the other type of inductor, but you generally won't see these days, so you don't have to worry about those. But these are really, really popular, and the reason why they're so popular is you might be thinking, oh, but if these are so notorious, like, if these cause all the coil whine builds, why does everybody keep using them? Well, these are electrically way better than these. These can take way more current. You can get them in much smaller packages. You can get them, like, they're just better. For GPU applications, they're perfect because you want a relatively low inductance and you want a very high current handling capability. This thing right here can handle probably 70 amps. This inductor right here, more like 40, right? And so if you're doing a VRM for a GPU, you're going to go with this, not that. Similarly, if you're going like doing a high-end motherboard, sometimes you'll see something similar to this style as well. And yeah, these tend to whine. So, and that's just unfortunate that their construction is so liable towards to doing that. And finally, I guess the last card I wanted to show is this right here. Now, I've never actually run this card under load because this has liquid metal damage and it just doesn't work. Like, it artifacts all the time and you can't actually put the card under load. But basically, I wouldn't think this would actually have too many coil whine issues. And the reason why I'm saying that is because if we look at the back of the card, those are through hole. So those are very likely this style of inductor. And then the input filters are also through hole right there and there. So this style of, like, I would expect this not to necessarily have a lot of coil whine. But if we're looking at modern GPUs, then this, like, more newer GPUs than this style of inductor is really, really popular. And these coil whine a lot. So yeah, that's just kind of that. And that's basically all I have to say. GPUs coil whine because they use a style of inductor that, while electrically is really, really good, acoustically lends itself really well to being a bit of a speaker. And unfortunately, because GPUs load cycle really hard, that means you get a bunch of coil whine as your frame rate goes up and down. So yeah, and if you want to try fix it, you're basically going to be looking at, like, dabbing high temperature silicone or hot glue on all of the inductors that use this style of construction. Now, theoretically, these could probably also work themselves loose over time eventually. It's just that I don't actually have experience with that happening. But the two, like, this style of construction, like, if I have a GPU with these, it probably has coil whine. So yeah, that's why I'm you know, blaming these so much and not these so much. Though admittedly, these are really unpopular on GPUs these days, so it's kind of hard to test how bad these really are. But yeah, also you might it's also good to keep in mind that a lot of GPUs will have a Say like some GPUs will have like a molded style inductor. Like I think Asus uses molded ones where it's like this style of construction where the core is molded onto the coil, but it still is like it's a larger package and it kind of looks like these guys. But I still think Asus uses this style of construction. But even then, if your VRM is built up entirely of, inductors that don't necessarily coil whine, you have to remember there's an input filtering inductor. That thing is still experiencing all of the power draw changes that the VRM is, right? Somewhat reduced, but it's still experiencing almost all of it. And it's still liable to coil whine if it's this style of construction. So, yeah. And this is also really popular as a construction style for input filters. So, yeah, that's kind of it. If you want to try and mitigate your coil whine, you're going to basically have to be looking at some kind of adhesive around the inductors. Also, if you're going to be doing that, keep in mind that your MOSFETs don't appreciate being covered in hot glue because they need to get cooled by something, and hot glue is an insulator. So yeah, like if you're going to be doing this, be accurate so that you only hit the inductors, and then you're going to have to wait for it to dry, check that everything dried the way it should have, and then reassemble the card, right? Don't like do it really quickly. I get that this really sucks and it's really like a pretty half-baked solution. I'm pretty sure you're also going to lose your warranty if you do that, because good luck removing all of the gunk you've just applied to the inductors. But I can't really think of a better solution to dealing with coil whine, because if you have inductors with loose cores and you push this through them, you're going to get whine. That's just what they do. Like there's no, and the only way to fix that is to make the core stop rattling around. And the only thing I can think of that'll do that is adhesive. Also, like thermal pads pushing down on the inductors can actually kind of achieve that same effect, which is potentially why if you go from like a stock cooler, which has a whole bunch of thermal pads on, all of the inductors and all of the MOSFETs and just everywhere, thermal pads just bloody everywhere, they can put them. If you have a cooler like that and then you move to something like water cooling where the inductors don't actually have anything on top of them, like pressing down on them, then it's possible that the inductors will basically be undampened, because the only thing keeping them in place is the construction of the inductor itself, and the construction of the inductor itself, and that's obviously worked loose if it's producing coil whine, right? So yeah, that's basically everything I know on the topic of coil whine. Oh, it's also worth noting that technically speaking, multi-layer ceramic capacitors can also produce whining sounds, but they're, as far as I'm aware, they're much more muted, and they shouldn't really, like, they shouldn't factor into this. It's really going to be the inductors that you have to worry about. So yeah, hopefully you find this helpful. As I said, I've never actually tested any mitigation methods. I have noticed that sometimes when I plasti dip some of my cards for running on LN2, if they coil whined before, they coil whine less or don't coil whine at all after I've plasti dipped them. But it's not like I've gone out and taken a card that I know has this amount of coil whine and run it without like air cool, right? Like taken it apart, run it on like water cooling so that I'd minimize the amount of noise the card is making, then test if, hot gluing the inductors or siliconing the inductors or whatever actually makes a measurable difference to it, right? It's just like anecdotal evidence is not great, but also the fact that Power Color used to put hot glue on some of their 290Xs, I think, is it's a pretty good indicator that that's probably your best option for trying to minimize coil whine, because or try to just put thermal pad, like put thermal pads to dampen the inductors somehow. Well, yeah, basically you need to somehow mitigate the vibrations, and there's only so many ways to stop things from vibrating, and yeah. So that is it for the video, and it is now way too damn long, but well, whatever. So that's it for the video. Thank you for watching. Like, share, subscribe. If you have any comments, questions, suggestions down in the comment section below, leave them there. That would be great. And if you'd like to support what I do here with actually hardcore overclocking, I have a Patreon and t-shirts. There's a link to both of those down in the description below. And yeah, that is it for the video. So goodbye.